All right, so let's look at one last example. A school district has 2 high schools. The district could only afford to hire 12 guidance counselors. We want to determine how many counselors should be assigned to each school using Hamilton's method. All right, so again, we're going to use Hamilton, and I will put a nice table in here for us to go do that. Okay, so I made my table. Let's go down below it, and let's get our divisor. And we're going to take our total, which I added up to be 21,564, and divide by the number of counselors, 12, that we are going to allocate. All right, let's do that division. And we get 1797 is our divisor. All right, so let's get our quota. So let's divide each of the 2 populations by 1797. So I'll divide 6246 by 1797. And that is 3.4758. And then I'll divide 15,318 by 17. And I get 8.5242. All right, now let's do our initial allocation. So just taking the decimals off using Hamilton's method, 3 and 8. So we have 11. All right, so we have one more to allocate to get the 12. All right, and let's look at our decimals, 4758 and 5242. 5242 is bigger, so Fairview will get the extra counselor. And now we've allocated and we have our total number of counselors. All right, so the next year a new school is opened, and that new school has 7,704 students. We want to use the divisor that we used above and determine how many additional counselors should be hired for the new school. So let's take our 7704 and divide it by 1797. And I'll just kind of show that right here. So we're going to take 7704 divided by 1797. And that gives 4.2871. So we're going to say we need 4 new counselors. All right, so now, given after we hire that many new counselors, so we'll have 4 new counselors, the district calculates the reapportionment, determining using Hamilton's method, and we want to determine the outcome. So I'll make another chart for us. So let's now find our divisor. So I totaled up my 3 school populations, and we want to divide by 16 counselors since we are hiring 4 new ones for this new school, and our new divisor is 1829.25. Now let's do our quota. All right, so let's take 6246 and divide it by 1829.25. And that is going to be 3.4145. And then let's take 15,318 and divide it by 1829.25. That's going to be 8.3739. Oops, lost my point there. There we go. And then 7704 divided by 1829.25 is going to end up being 4.2116. All right, so let's remember with Hamilton's, we just take our decimals off for our initial allocation. This time we are allocating 16, and if we add these up, we've allocated 15. All right, but it is Hamilton's method, so we're just going to allocate that one additional counselor to whoever has the biggest decimal here. And if we look, Lowell right here has the biggest decimal, so it's going to get one more. And that's going to give us 16. Now let's notice that we expected for the new school to get 4 new seats. We actually figured that out before we started the actual allocation process. But let's notice this. Lowell gets 4, Fairview gets 8. What happened before the school was added? It was reversed, or Lowell had less and Fairview had more. So Fairview, with this new school added, lost a counselor to Lowell. Well, that shouldn't be happening because all we did was add another school and we added additional counselors to make up for that. So that is a paradox. Let's see which paradox it is. And we can guess, since I've done 2 examples already of paradoxes, that it is a new states paradox. We added a new state. In this case, it was a new school. Someone has to give up seats to accommodate. Well, we didn't have to do that because we actually proportioned out 4 new counselors that would be for this new school. But what we had was someone gain a seat and somebody else lose a seat, even though we had sort of made that adjustment for the new school. So this is a new states paradox. This one, of course, is easier to spot in your homework because you're adding a new one to your table when you do the apportionment.